Cool. Can you see my screen?
Yep.
Cool. Okay. Yeah, so I wanted to, I guess, continue with this stuff. But the last time where we left this is we had a couple of things to fix up. And I don't know if we're going to get an hour's worth out of this. Maybe not, depending on how like as we discover things and if yeah, how many questions and things like that come up. But I thought we'll just let's start working on the issues that we had.
Sounds good.
See where it progresses. So if we just have a quick, because it's been a few weeks, so if we have a kind of a quick look at the top level function here, which is this contract function that takes the number of participants and basically generates this crowdfunding contract for all of them. So we've got these special cases for 1 and 2, because you need at least 2, and then 3 onwards is like is recursive. So,
and this is relating to the outcomes of the success of the crowdfunding, the contract payouts.
Yes. So we had a few things that we needed to fix around that, basically. So let's just compile it and view it in Blockly. So send to simulator and then copy it. Blockly. Let's just open another. Source. What have I done? Oh, a new project.
No worries.
I guess Marlowe here. Like that. Yeah, cool. And then we can no. Cool. So this was our
crowdfunding contract.
Yeah. Sorry, I was just trying to zoom out. I can't pinch, but I can click these. Okay, cool. So it's quite big. So I guess the first thing while we're debugging it is I'm going to make it smaller again. So let's do that. So we'll make it 3, size 3, which is like kind of the, I guess, the minimum size above those 2 mandatory ones that we got to have, just to make it
a little bit more manageable.
Yeah, we can always crank up that number when it's ready. Okay, so it's still huge, but that's okay. Now, so yeah, so we have the startup deposit some WTIM tokens, and then we have investor 1, investor 2, and then investor 3, basically the deposit. And if there's, well, let's go to investor 3, I guess, because that's maybe investor 2. So investor 2 deposits, and then we look at if their deposit is less than the available currency here, then let me just have a look.
If their deposit was less than what was available, in the crowdfunding pool, then it was it's allowed to go on. If there's not enough of the startups the startups token in the pool to meet their deposit
Yeah.
then it
Yeah,
would,
yeah.
yeah.
Yeah, sorry, that's right. I stated this wrong. So this is the choice. They make a choice first, and then we look at the choice to see if it's enough, and then we allow them to deposit here.
Yep.
And then if there's more tokens available in the pool, then we go to investor 3 and so on. So, and then once everybody's kind of done, then we pay everyone their tokens.
Yep.
So the first issue that we kind of discovered towards the end of the last lesson was that this doesn't quite work. And the reason this doesn't work is because we pay out everything at the end. So this available currency of WTIM is actually just not affected by these deposits.
Yeah, it's always seeing the original deposit and not what's
Yeah.
actually what's available at that time.
Yeah. So that's basically the problem. So my proposal to do instead is we're going to keep a variable, and we're going to add to that variable, or maybe I guess subtract from that variable the amount of WTIM that's already been bought. So instead of looking at this available currency, we're going to look at the value of the variable. That's roughly,
yep, that makes sense.
That's roughly what we're doing. So basically, instead of this, we're going to have WTIM left. Sorry, I'll zoom in a little bit so we can actually see it.
Thank you.
That's roughly what we're doing.
Gotcha.
Instead of this. So the only thing is, like, I'm just gonna get it roughly going here, and then we'll move it into Haskell. But it doesn't even have to be fully populated. Just the idea is the important thing. So I guess at the start, right after this deposit, we want to set this WTIM left to be equal to this amount. So that's easy. We use a let. So WTIM left, and we'll make it equal to this constant there. Right. So that's just creating this value here.
Okay.
And then
gotcha now.
And then that goes there, right?
That's the starting of the variable.
Yeah, that's right. Now these yeah, we'll have to explore this a little bit, but I believe the way it works is, yeah, then every time you want to update that, you have another let, which kind of replaces the previous value of it with a new one. But yeah, we'll have to do a bit of an experiment to make sure that's the case. In fact, let's open up one more window and just do a small, just to kind of show how these lets work, because I think it's probably easier to do in a simpler contract than ours, and then we'll transfer it back to ours. So we'll start off with a when we'll just do a deposit at the top. Action deposit by party. I don't know. Donor. The amount of 100, whatever, of data into the account of into their own account, and then we'll continue as that can be a close. So that's just a deposit at the start, and then we'll do this let. We'll call it amount, and it can be 100 at first. And then let's suppose somebody's deposited, but we don't have to do that part in this. This is just a toy, really. But let's say that somebody's deposited 50, so we want to subtract 50 from this amount, right? So what that is another let. And now we go here. First of all, it was 100, but now we want to make it equal to, now we want to make it equal to 100 minus something else, or
Okay.
rather, we want to make it this amount minus something else. So it's a value, it's a minus, and then what minus what? Well, it can be minus like 50. And this part here then is the actual current value of the amount.
Gotcha. Okay. Now I'm tracking.
Yeah, so we're saying amount is update amount to be equal to the previous value of amount minus 50.
So in our case, we need the second let to be always subtracting whatever the investor took out of the pool.
Yeah, that's right. So this will be, what we want to track with our variable is the amount left in the pool. So every time an investor deposits, we want to subtract the amount of tokens the amount of WTIM tokens that they are now owed from this total amount. Yeah.
Gotcha.
And then let's pay something just to kind of make sure that this all works. Because assumptions will kill you if so we can pay the that's payee. So we can pay them ADA again. From the account of donor. And the amount can be this username amount. So we expect this to be, let's make this 40 up here. So we expect the payment to be 60, right? We start with 100, and then we subtract 40 from it. So 60 should be remaining. So let's run that. What's going on?
No inputs can be added. We're missing something in the contract.
Yeah, we must be. Because it should be when deposit. No, not that contract, sorry. What's going on? Let me just copy this because I have a sneaky suspicion that we've lost it.
Maybe the Marlowe playground only lets you have so many instances live in your
potentially
IP or something.
Oh, I think this has to be higher. Maybe it was just that because we remember, yeah, because we were waiting for a deposit, but we didn't have this timeout there. That might be it. So initial, okay, cool.
Oh, there you go. Yeah, there was no time to make a deposit with 0.
Yeah. So we deposit 100. And no, yeah, we did it wrong, right?
No, you did it right. It's just because there's only one role in this whole contract.
Yeah, we'll pay to the receiver just from the donor. That's what I meant to say. Cool. Okay, so 100. Yeah.
Yeah.
So donor gets their 40 ADA back and a receiver gets 60. So yeah, really what I was trying to demonstrate is just this let and this idea that you can upgrade, like you can kind of update variables based on their previous values. So you start off with something and then you can subtract something else from it to have a new value.
Yeah,
And
that's cool. I never understood what the let
yeah, so that's what that is, which is good because we're going to use it now. Yeah, so WTIM left, and now we had if the WTIM left is greater than or equal to 10. That's right, because that's the minimum amount they can buy. Yeah.
Yep. The having to be greater than 10 was just because that's the minimum amount that needs to be in there. That's the 10 is the minimum someone can get in this contract.
Yeah. Cool. Yeah, basically. So we have checked it, and then investor one deposits, and they choose and then deposit, and then we do that check again. But before we do the check, we have to actually update the
this is where the let needs to subtract whatever their choice was.
Yeah, exactly. Yeah. So we'll go into get a let. And that'll be called WTIM left. By the way, I'm using these underscores to separate words. That's just kind of a programming convention. You can probably do that as well.
No, just stick with what you were doing. I think it's good.
Yeah, cool. Just so you, yeah. So now we want to do subtract. So we subtract from WTIM left. So from that, let me zoom in a little bit too, sorry. And now what do we want to subtract? Well, we want to subtract 10 times the deposit, yeah?
Yep.
Cool.
That's making a lot of sense now. I'm seeing where we're going.
Yeah. And then, so we've subtracted it, and now we can, where is our if? This guy. Cool. So that's cool, like that. And then we'll kind of recursively go into this shortly. I don't want to kind of manually do it all through because we're going to have to do that. But the other thing we have to replace is this, right? So this is that check that when they choose a deposit, they haven't chosen more than is available. So also here, just like before, we have to do WTIM left. So we use that in two places. One is to decide whether the next person should even get a choice, and then when they make a choice, to also decide whether there's enough to
makes sense.
Yeah. And so we've got investor 2. Let's just quickly
duplicate the blocks on the other ones.
Just for number 2, maybe, I guess. So this
As well, it don't take very long. It's pretty easy.
Yeah, and that way we can test it, right? Otherwise, we won't be able to test it until we get to the Haskell, which is not ideal. And then we've got that one. We're going to have to update the WTIM as well, which we'll do in a second. And then investor 3 does the same thing. So there.
I think those should stay the same because those are actually based on the pool, not on the left.
Yeah.
Yeah.
Yeah. So those are okay. Yeah. Cool. That's yeah. I understand. So this is checking whether there's enough money in the, like, basically whether we're done. Cool. So that's all there. The other thing is we have to, so after investor 1, we've done the let. So I'm just gonna like duplicate this because we're gonna have to do it again after investor 2 is done. So investor 2 is deposited. I'll just drag this down a little bit. So that goes there. And then we go do a let. So after investor 2 is deposited, we update the WTIM left to be minus the deposit from investor 2 times 10. And then we follow it up with that. And then investor 3 does the same thing. And then we're kind of done because we.
And I think you were right on this, the last if that you can see down there, available currency ADA from account pool is greater than, I'm just trying to think, is that if the value of ADA from,
so this is checking if we've reached a payout limit, right? Like if we've satisfied the.
So this one isn't actually this isn't checking anything to do with the balance of the WTIM. This is all how much ADA has been deposited.
Yeah. And like just to be clear, we could have phrased this differently, right? We could have expressed the same, like we could have said, well, our crowdfunding goal has been satisfied when this amount of money has been reached, but we could just as easily say it when this number of tokens have been sold. So we could do it in terms of WTIM left. It doesn't really matter. It's the same principle, right?
Yeah.
That's just whether, if we're selling BMWs, we can say we're done for the day when we've sold 3, or we can say when we've made, I don't know, $300,000. It's the same.
Yeah, gotcha.
Anyway, so this is our.
I don't think you updated investor 3 yet, though.
Let's have a look. So
you didn't add the let to investor 3.
After investor 3 does it, but I don't think I have to because we are done at that point. Yeah, because we're not like, I mean, in practice, yeah, you can. Let's just do it then. It's fine. So just to kind of be consistent. So the reason I didn't do it is because we don't really use it after this.
I got you now. Okay, that makes. I see what you're saying.
Yeah. But obviously our recursive function is going to do it for all of them. So let's just keep consistent. WTM left, was that what it was called?
Yep, WTIM left.
Okay, and then we'll copy that. That block there. And it's from investor3. So yeah, I mean, just when we're doing it manually, we can skip this part, but it's obviously better not to.
You better save too. I'm just thinking it's been a while.
Yeah, this is a temporary thing, but yeah, save as I don't know, Marlow version with let, something like that. Because yeah, this is not editing the Haskell one. This is editing like a copy of what was generated from Haskell. Anyway, let's try it. So technically, we should be able to. So we start off with like. We should be able to give investor one, basically buy out the whole pool from investor one, and then that should be us, right? Like investor two shouldn't get a chance.
Yeah, that's true. It's some.
Yeah. Okay.
I can't remember what we set, if we set the maximum max investment allowed to be the maximum pool, or if we set it smaller than the maximum pool. I can't remember.
Okay, well, we'll just go to the max investment. I don't remember either, actually. Deposit between, hang on, choice. Oh, well, that's the.
There you go. Yeah, that was the max.
Cool. So 50,000 units of ADA, which is I think was it 500,000?
Yeah, go ahead and deposit. Let's see what happens.
Cool.
It'll close if it's. So that's not maximum pool. That doesn't take the whole pool.
Yeah. I feel like at this stage I have to look at. Okay, let's just go with it, and then. Okay, so we'll go maximum again, right?
Yeah, let's just try. Let's do 3 maximum, see what happens.
Hopefully 2. Cool. Okay. Yeah. So the two investor 1 and investor 2 did the maximum, and investor 3 doesn't have the option of entering. Yeah, investor 3 didn't get a chance basically because it's already like.
But we do have a problem because neither investor 2 or 1 received their WTIM.
You're right. Oh, that's a big problem. Let's fix that. Yeah. Just before we do that, let's just do minimal investments and make sure that we can that works.
Yeah, just the 10, 10, 10.
Yeah. Oh, and then that refunded because we didn't reach the funding
Didn't
goal.
reach the minimum funding threshold.
Just before we go on, what I want to do is take some notes. I want to take some notes on like, yeah, let's just work out some numbers so that we can test correctly, because I don't know what's going over, what's going under, and stuff like that. So it'll take a minute, but I think it'll be helpful. So the total. So let's see, our funding goal was 50,000 ADA.
That's the minimum threshold.
Yeah. So min.
And 100,000 was the maximum threshold.
Okay. Okay, so the minimum threshold is 50,000 ADA. Cool. And then the max deposit is, oh, sorry, and we come in with, what's this? How many zeros are here? 1 million of these. So that's 100,000, yeah. So max is 100,000. Okay, cool. Just, and then I guess max deposit is 50,000. Okay, cool. Just wanted to write these notes down.
Yeah, it's nice to have kind of in your
like,
reference in your mind.
Just so you know, like, so if we do 10,000.
That's the slot.
Oh, that's a slot, sorry. There we go, 10,000 for the first one. And then 40,000 for the second one. And we might have just been off by 1 ADA. Okay, so that one pays out, but if we do it slightly differently, so
that one paid out WTIM? I didn't see it.
Yeah, I did.
Okay.
Yeah, but that's within limits, so that's the happy case. But now if we do 30,000 each. Because no, sorry. We've got to do.
Well, just do 30,000. That still
Okay.
makes it, that's in
Let me
between the
just
two.
change the contract slightly to make this a little bit easier. I'm gonna just here do like slight, just reduce that a little bit. So just because otherwise the two first, yeah,
you better change the constant. You better change the let right
just to make
below
sure we
it.
can go over it with two investors.
You still got to change the let.
So now initial slot is 0, and then we go 50,000 for the first one, and 50,000 for the second one. And now we should have gone over the number of WTIM tokens at this point. So let's see what happened. Investor 1 chose 50,000, investor 2 chose 50,000. So
yeah, no one was paid out WTIM.
yeah, okay. So this was a ripoff now. If we went over the limit, the pool got the WTIM and the ADA. Cool, we got to fix it. Okay, great. So let's just work out how we fix it, and I'll just do it on the inner thing here where we just made the observation. So yeah, if we've got more than 10, then we do all this. So what we've got to look at is the else part. So yeah, I guess like we've got to do the payouts on this else part to everyone so far. So we've got to do these like because at the moment we're just closing the contract if this investor 3 doesn't get a payout. But instead, we should be doing this pay for investor 1, pay for investor 2, but not investor 3 because investor 3 didn't participate. So like at every point, every time we get one of these decisions, like if investor, I don't know, say we're up to investor 5 and there isn't enough money for them to go in, then we've got to pay out investors 1 to 4 and finish like that. So I'm not going to do this in Marlowe because it's like too hard to do manually, but we'll address it in the Haskell, which I want to go to now. So yeah, basically we'll do the let thing and then we'll take care of the if else part as well.
Sounds good.
Yeah, it's a little bit daunting to try to do manually in here, but I think in Haskell we have all the pieces. We just got to fix it, kind of fit them together. Yeah. So, sorry, where were we? One thing I do want to do though is get that let part, because we're going to need it in the Haskell. So basically this is our Haskell, and let's see. So this is our if. So instead of if, what we want to do is after every, so at the beginning, let's do a let first. So that's so yeah, here. So in the case of a deposit, we'll do this later, but we'll also do a let WTIM left. So we start off with, I presume that's the true number. Yeah, that's correct. Yeah. And so we'll start off by that. So we can just use that variable there. But now when we go to save choice and deposit, yeah, so we've got this if the value is greater than, if the available money in the pool is greater than there. So instead of available money here, we have to look at use value.
Gotcha.
Yeah, that's right. So that's kind of it. So we got that here. And where else do we use available money here? So anywhere where we're looking at WTIM available money, we have to replace with WTIM left. This one's okay. Cool, so that's that. And then, so we've done that part, but now we also have to, if we go to the actual choice and deposit thing, when after the deposit, here, we want to do a let before we carry on the next contract. So it's basically, let's find the update here. just trying to match up these brackets. It's always a pain when let me just actually, yeah. So I think that's matching. Let's see. So we've got the let there matches to.
We missed
should
let
match
is
to
in
that.
regards
Let's
to,
just try and compile it and see what it says.
that's at the bottom, I believe, isn't it? The error that it's having.
Okay, so at this point we should have still been okay. No.
Can you hear me? 10?
I'm just going to wind us back a little bit and just make sure that.
Can you hear me?
Yeah, can you hear me?
Yeah, I can hear you. Okay.
Can you hear us, Boone?
I can hear you. Can you hear me?
I mean, sorry, I can't hear you. Oh, so it's, let me check. Speak?
Hello? Hello?
Yeah, okay, we're good now.
Okay.
I don't know. Sorry, things were a bit quiet for a while.
Yeah, I thought, well, one of the things I was saying when you tried to compile, I think the error you got was at the bottom. Remember you
Okay.
copied and pasted that, oh no, you moved it. Okay.
No, but you're right, actually. Let me just wind back a few. Yeah, that's it. So yeah, it was that it should be like this, I believe. Let's see if that compiles. Yeah, cool. So yeah, I had that in there. And yeah, okay, cool. So then the next thing we wanted to do was this use value WTIM instead of available money. Not for the ADA, but here. And also here. So that should still compile.
Nice.
Cool. And now at the end of every deposit, we have to update that. So we've got a deposit here, and then this is where I was going. So basically, inside of that next, we want to update that WTM value. And we want to do some indentation, and I believe now we should be good. So yeah, so it's a let, that's the value, that's the name of the variable, and it's this, we do the sub value thing. Except that instead of saying investor one, that should say investor role, like, so it's general. Yep. Still not quite aligning for me, so let's just see if
Nice.
Seems good. I guess we'll put this brace at the end of Yeah, it looks a little strange, but it's fine. So yeah, basically we've done this WTIM left. Now I wish I don't remember. Is there a way of what's this? Don't want to go check that. No, there's no, it would be nice to be able to kind of log things in the simulator to see that value update, but I don't think we can. Let's see.
Display the variable.
Yeah, in the logs, that would be really quite useful, but I guess I'll just quickly have a look.
Yeah, because right now now that you mentioned that, is this contract in the way it flows goes, is it actually just going to be looking at the let minus the last investor or the total of all investors?
No, so it's it should be going the let should subtract that new value from update the new value by subtracting the amount from the last value of the let.
Okay.
So
Okay.
that means that it's all investors.
Gotcha. Okay.
But let's run it and see if it does that. Okay. So we'll deposit. I guess we want the happy case, so 30,000 each.
Nice. They got their WTIM.
Yep. Now let's do 50,000 each. So then only the first two should get a choice, but it should work. So, and remember that they're not going to get their WTIM because we still haven't fixed that other issue.
Now, where are we at on this issue in the contract? Why is it, even though it was a successful raise, why weren't they getting their WTIM?
Yeah. So I can show you in here what the problem was. And then I remember I said we'll fix it in Haskell because it's going to be too hard otherwise. But basically what happened here, right? Not here, but here. So we did an if here.
Yeah.
Right. And if there's enough money left for the next participant, then fine. But the problem is that
there wasn't enough.
And if we look at the else part here,
we don't have the pay in there. Gotcha.
So we got to pay them out basically.
Yep.
At this stage. We got to pay out everybody up to the investor that we're up to, but not the future ones. That's basically.
Gotcha. Now I see where we're at.
Yeah. So that should be pretty easy, right? Because we already have payouts or refunds.
Yep. We just need it in this instance.
Yeah. So let's find it. So we got payouts or refunds, and what I want to emphasize here is that takes the number of people to pay out. So it'll pay out from 1 to n, and that's really useful now because we're going to be able to pay out to not to
100
number. Yeah. Or so if we go here, choice and deposit, hang on, safe choice and deposit. So here's the problem, right? So safe choice and deposit, remember, checks if there's enough money left for everybody, and then it if the answer is no, then it just closes. So I think what we want to do here is do payouts or refunds instead.
That makes sense. And then close.
Payouts or refunds will close.
That has the close command in it.
Yeah,
Gotcha.
yeah. So payouts or refunds, and we got to be careful with this one. So payouts or refund takes an integer, which is the number of investors to pay out. And remember that this choice and deposit is basically doing for the current investor, it's going to check if there's enough money. So we want to pay out all of the investors up to not the current, but the previous. So if we're on number 3 and there's not enough money for number 3, we want to pay out 1 and 2.
Gotcha.
So that means here, this investor index, we got to pass it to payouts and payouts or refunds and subtract 1 to go to the previous rather than the current, if that makes sense. Because we're kind of going 1, 2, 3, 4, 5. So we're up to 5. We want to pay out 4, 3, 2, 1.
Gotcha.
So I think in my generally optimistic style, I think that should work. I think that should be all we have to do. We'll see.
Good to go, it says. Let's see if it works now. 50K, 50K.
Yeah. So 50,000. $50,000. Moment of truth. Awesome.
Nice.
So we got yeah, so we got investor 3 didn't get a shot, and we got 1 and 2 paid out correctly. So that was cool. You know, that you can see why I did this in Haskell, because it was like quite trivial, because we already had all the parts, whereas trying to do it in Marlowe directly would have killed us. Just because it's gets a bit too big and you'd have to do all of the recursive cases and all of the. So we can generate this for a bigger number of participants. Let's say 5, just to make sure it still works.
Yeah, let's go in and do just keep doing 30,000 on the simulator until we hit the deadline.
Yeah, so that should be the first three should be allowed, and then the fourth shouldn't
work.
Yeah, cool. So 30,000. $30,000. Oh no, that's fine, actually, because number 4 should get a shot because they have the opportunity to buy less.
Yeah. Right? So go ahead and let them put 10 in.
Yeah. 10,000. Yeah.
I think that takes it right to the cutoff.
Yeah. The limit. Let's just go 9. No, we've got to do.
Try 10,000.
9,999. Right? Just one less, because what I want to verify is that there's still a little bit of money left over, but it's not enough for them to actually buy anything. So that should be.
Makes sense. Ugh. Yeah, try to have him put 10 in now. Shouldn't work.
Now let's see what happened. So he, investor 5 chose value of 10. Okay, so
no one received their WTIM again.
Same problem, but in a different place, right? So we did this. Where's that if? Sorry. Looks like that. So we had 1 here, But, and again, here, what happens is, it's a big if. So I guess it's if the value is less than that, then we do a when. Otherwise, we close. So this should not be a close again.
That should be the payout and refunds.
Yeah, just like before. I think it's basically exactly the same.
I think you're right.
Yeah. Yeah, so that should be it. And once again, it's, you can just imagine the pain of trying to do this directly in Blockly. This is where you see some Haskell value, even though it's,
well, yeah, and I mean, this, we're still using small numbers compared to what one of these contracts would actually, most of the time, if you do something like this, you're going to have hundreds or thousands, not two people come in with half the pool amount.
Yeah. Okay. So let's do 30,000. 30,000. 30,000. And now he can do something that's over, but
we'll have him do the 9999 again, and then investor 5 try the 10 one more time.
Yeah.
There we go. Perfect.
Yeah. So yeah, that's what
everyone got their WTIM, and investor 5 wasn't able to deposit because there wasn't enough for him to get. So
no, not quite. He still paid the 10.
No, it didn't. That's the 10. That's the leftover WTIM going back to.
Oh, that's the WTIM. You're right. You're right. So all is good.
Yeah, all is good.
Yeah. Cool.
Nice. Well, we came right in at an hour, dude.
Yeah. Perfect. So you can see kind of how, even though they look like small things, I guess it takes a while to analyze and
Will you save that and send me the this latest update, please? Yeah,
I will. Yeah, so I guess like what I wanted to emphasize though is that these, you can see we're kind of not really, like, over the last couple of lessons, we haven't really like been doing any radical new concepts, right? We've been working with what we already know, but it still takes a while to get the contract right, kind of thing. So you can see kind of the development process of, I guess, building this thing up and doing some testing on it, realizing these edge cases, and then kind of coding for them.
Yeah, I think that's really the power of the simulator, is to be, being able to try out multiple different paths in the contract to find these little things that you don't really think of right off the bat.
Yeah. So there's, cool. So I think that's the kind of end of the lesson. So
yeah, that's
you can stop recording. I want to talk about where to go with this from.